So let's continue talking about how to identify three-dimensional shapes or geometric solids. So we have this picture here and need to figure out which one of these choices that it is. So first of all, it's not going to be a prism because one of the bases here, either the top or the bottom, this is curvy. And prisms are formed by polygons. So the base would have to be like a rectangle, a triangle, a pentagon, an octagon, something like that. So this isn't a prism, and it wasn't composed of all rectangles anyways. So that narrows it down to between a cylinder and a cone. And these are both fairly similar. The difference is that one of them comes together in a point, and the other one has the same size shape for the top and the bottom. So this is in fact a cylinder. When you have a circular base, and you can imagine sliding it up or down so that it fits perfectly through the shape, it's very similar to a prism. It just doesn't have a polygon as its base. But you can imagine sliding it either up and down and it perfectly fills out the shape so that the top and the bottom have the same size area. And you can imagine if you cut out some section along the way, this will be a little bit hard to draw, but if you cut out a cross section, then that cross section would also have the same area. So that's how you determine a cylinder. This is like a soda can would be in the shape roughly of a cylinder. Now, a cone, like I mentioned, is very similar. It's going to start with a circular base, just like this. So let me try to draw that in with a little bit of perspective. But with a cone, instead of having it slide up, what's going to happen is that every point on the edge of this base is going to meet at some point above. So if we use a line tool, we can essentially take every point on the edge of the circle, and they're all going to meet at this same point above. So this is what we call a cone. And you might recognize this could be like the base of some ice cream cone. Maybe it's upside down where your ice cream is right here. So cones, specifically every point on the edge will come up to meet at that top point. So let's look at another example problem. And we've got this other 3D shape here. And notice that this is a prism. And in fact, this is a triangular prism. We looked at that in the introduction video. We know it's not a cone, we just looked at that. That has to have a circular base. And a rectangular prism essentially would have all of its sides, all of its bases be rectangles. But this one, notice we have this base here on the top and the bottom. These are both triangles. And we know it's a prism because you can imagine starting at the top and sliding that triangle through the shape so that it perfectly fits through it, and the bottom size triangle is the exact same size as the top. So if we were to cut out some section of this, a cross section of our shape as we go along this length, this cross section would also be a triangle. That's not drawn that well, but you get the rough idea. So because we can take one of the bases and slide it through perfectly, we know it's a prism and it has a polygon as the base, specifically a triangle. So that makes it a triangular prism. So let's do one more problem. And this one is a pyramid. You might be familiar with some of the more famous pyramids, but these are named because they have some kind of polygon as the base. So notice this one has a square as the base. Let me draw this out roughly, and let me use the line tool. So a pyramid has some polygon as the base. In this case, it's a rectangle. And then each corner of that pyramid is going to go up above and connect at one point. So it's going to look something like this. or this shape right here. So the main idea with a pyramid is that they all meet at one point, which is very similar to a cone. Since, again, remember with a cone, it has a circular base, and then every point on the edge of the cone is going to reach up and connect at the same point above. So it's the same type of idea that you have some base and then all the lines coming from that base reach up to connect at one point, and the lines could also be coming from the side here to reach up, but all lines from the edge reach up to the same point. So pyramids and cones are similar, but a cone has a circular base, whereas a pyramid has some type of polygon as the base. And it doesn't have to be a square or a rectangle. This one, in fact, is a square pyramid. All right, we know it's not a prism because prisms would translate perfectly above and you'd have another rectangle or a square at the top. So it's not a prism, and we know it's not a cone because it doesn't have a circular base. So that's how we know for sure that this is a square pyramid out of the three choices. But you don't just have to have a square for your pyramid. We could also maybe have a triangle. So a triangular pyramid would just have a triangle for the base, and then each of the corners would all reach up and connect at the same point above. And again, it doesn't just have to be the corner points, it could be any point along the pyramid. It just gets a little bit messy to draw that. So this is a triangular pyramid, and if you add a pentagon for the base, you can have a pentagonal pyramid. So pyramids have polygons as bases, and then all the edges reach up and connect at one point above.